Okay, ladies and gentlemen, today we're going to get into 7.2, multiplying polynomials. Okay. All right. Hey, so the first part here, we kind of spoke about this the other day for those of you who did the extra credit, but when we're multiplying polynomials, in this case to start with a binomial times a binomial, your student journal talks about this method called the FOIL method. Okay. And I personally don't use the term FOIL all that often unless I'm saying, oh, you know, like the FOIL method, because I like to call it more the distributive method. It's a method that you will use, the kind of a quick method that you'll use to multiply these. But if you use FOIL and you have a binomial times a binomial, okay, what they try to do is use these letters here to abbreviate what FOIL means. So F means first. You're multiplying first term by first term. So first terms, you get x squared. O means outer, so you're multiplying your outer term by your outer term to get 2x. Inner is I. You're multiplying your inner term by your inner term, so the two inside terms to get x. And then L is last. You're multiplying your last by your last to get the last one. When you combine all of this, x squared, 2x, x, and 2, these two go together to make 3x. You end up with x squared plus 3x and plus 2. Okay, since they're all positives, there are pluses in between. That's FOIL. Now, what I will do is I will talk to you about that as like the distributive method. Okay, so if you look at page 212 in the student journal, I would say I would use the same process. I'd say, hey, take this term, x, and multiply it by x to get x squared. Take x and multiply it by -1 to get negative x. Take -2 and multiply it by x to get negative 2x. And then take -2 and multiply it by -1 to get positive 2. Now you'll note when I wrote those out, I didn't put them in a straight line. You can. I didn't. I like to stack my like terms like this, probably because that's the way I learned it. Okay, but here's x squared. It doesn't have. There aren't any other squared, so I'm adding down now. Here's negative x and negative 2x is negative 3x, and there's only a plus 2. So by using the distributive method, you're actually doing FOIL there. Kind of the same idea. Okay, now before we go on to the next piece, are there any questions on that? The other process you could use is what's called the area method or a box method. If you think of a rectangle has area equaling length times width. So if I were to draw a rectangle and think of this is my length and this is my width or vice versa, and I wanted to find the area, well, if I assign like a weird length to this and say, hey, I'm going to multiply x minus 2 by x minus 1. Okay, and I would go through and break it apart. Yeah?
How did you figure x squared?
Right here?
Yeah. No, like the first one. Like, how did you get x2 and x?
Right here?
Yeah.
So I go x times x and x times -1. So I multiply this. To get this top row, it's that times that and that times that. Okay? Okay, so this gives me x squared. This is negative 2x. This right here is negative x. -1 times -2 is 2. And so now you could look at it and go, well, there's an x squared. I can put those two together to get negative 3x. And then I've got a plus 2. You get the same answer using either method there. Okay? I like this method more when I'm multiplying like a binomial times a trinomial. So 2 terms maybe by 3 terms. Okay? You'll notice they kind of give you that option down here. So if you look at number 7, go ahead and fill in your outside boxes here with, think of this as your rectangle. Fill in your outside boxes with the pieces. Okay, so this is x, that's -3. This is x, that's -2. Go ahead and multiply it out. All right. How many got? Okay. Any questions on it? All right. I want you to try number 10, right below it there. Actually, before we do 10, do number 4. Try number 4 using the FOIL or distributive method first. All right, check it out. Good? Okay. All right. Any questions up to that? So really that's a times a, which is a squared times 2. Okay, good question. So that equals 2a squared. All right, hey, I want you to turn the page. We're not actually going to do that bottom one yet. On the next side, go ahead and read the directions there. Tell your neighbor how you're going to complete those 13 through 18. Okay. Hey guys, this says FOIL method. Once again, I like to think of it as distributive method. I don't like to kind of distinguish between the two. If the box method works better for you, on another, like on tomorrow's assignment, I'll allow you to use whichever method. But today I want you to try, when it says use FOIL, first, outers, inners, last. Same idea as the distributive method, right? Okay. The part that gets a little tougher on this assignment is when you get down to, say, 19 through 24. So take a look at those. You have a binomial now times a trinomial. So when you're doing this one, go ahead and talk with your neighbor about how you're going to actually multiply that out. What do you do differently from number 19? Okay, volunteer, what do I do differently?
That.
Sarah.
You take your first term, you multiply by your first term, and then multiply your second term, and multiply by your first term, and same for the second number.
Good. Go that, times that, times that. Then that times that times that, and that times that. That's one method. The other option, you can go about doing it that way. You get x cubed, and you go there times there. X times x is x squared. X times -1 is negative x. -2 times x squared is negative 2x squared. -2 times x is negative 2x. And -2 times -1 is positive 2. And then combine. X cubes. If you've stacked your like terms, it's a lot easier. And that's your answer. That's one process. The other process is to use the box method again, okay, where you actually draw an area model. And a lot of students will do much better with this when you're doing a trinomial times a binomial. That's supposed to be a plus right there. All right. And you can draw the whole box, or you can just draw the line like a tic-tac-toe looking board, but either way. Kind of that same process right there. And then combine like terms. They're just not stacked there. They're kind of diagonal usually. So you'd have your like term there and there. Okay? Any questions? All right. Your assignment is to finish the extra practice.